Hmm? Mhm. Okay, so this is the problem, and so how should we going to approach it? Yeah, Shubrita.
মানে ক্যারেক্টারিস্টিক ভ্যালুটা তো একমাত্র জিরোই হবে।
Very good. So
তো
PTX, that is the characteristic polynomial of t. It is what? This is x to the power 4. So 0 is the only possible eigenvalue. So if t is diagonalizable, so if t is diagonalizable, t is similar to okay, call it A. So rank t is equal to rank A equals to 0. Is implies A, B, C all 0. Okay, so what about 7? How
ওই
to do 7?
টি মাইনাস সিআই যে অপারেটরটা,
Hmm.
ওই অপারেটরটার নাল স্পেসের সাথে তো মানে ডাইমেনশনটা সমান হতে হবে টি এর, তখনই ডায়াগোনালাইজেবল। তাহলে যদি ডিস্টিংক্ট ভ্যালু হয় তাহলে তো নাল স্পেসের ডাইমেনশন এন হয়ে যাচ্ছে টি মাইনাস সিআই অপারেটরের।
Hmm.
তাহলেই তো মানে এটার
Hmm. Okay. She is using this.
Dada,
Yeah,
Dada, can I tell in another approach?
of course. Why not?
Since here it is given that there are n distinct characteristics values,
Hmm.
so it's say lambda 1, lambda 2, lambda n. Okay, so its characteristics polynomial should be x minus lambda 1 into x minus lambda 2 dot x minus lambda n, and so its minimal polynomial will also be some constant into x minus lambda 1 into x minus lambda 2 dot x minus lambda n,
Not some
and
constant.
we have a
Just
result
that
that
product because is
sorry, yeah, just that product. Its characteristics polynomial is same as that of the
Hmm.
minimal polynomial, and since we know that there is a
No,
result
that's the
that
thing.
t
That's
is
the thing.
diagonalizable.
That's the thing. We haven't yet proved it. Otherwise, this is a straightforward application of that theorem. What you are saying, that if the minimal polynomial
Exactly.
splits in linear factors, t is diagonalizable. But we haven't yet proven it.
Okay, sir.
Hmm. The approach is correct actually. See, for t is what should I say? So I think we have proven one thing. In the last class, I think we have proven one thing, that eigenvectors corresponding to different eigenvalues are linearly independent, right? We have proven it in the last
Yes, sir.
class. So say lambda 1 to lambda n are the eigenvalues, and Divya and Ogniditya, if you don't understand something, please let me know. And Vi to Vn be the corresponding eigenvectors. Okay, that is AVI lambda AVI, I running from 1 to n. And V1 to Vn are linearly independent, right? So if you evaluate T with respect to this basis, what is TV1? That is C1 V1 plus 0 V2, so on, and this way TVN is 0 V1 plus Cn Vn. So T with respect to beta, it is C1 to Cn. Okay, or you can actually you can directly use this theorem 2. T is diagonalizable if and only if uh, this happens. Summation di is k. So in this case, k equals to n and di equals to 1 for all I. Okay. Okay. So what about 8? মা বললাম দরজাটা দিতে। Okay, so invertible. So they are saying that if I minus AB is invertible, I minus BA is also invertible, and this is okay. So see, I mean, this is very pretty easy. Just compute, just multiply this side. So just multiply this by I minus BA. Sorry. Just multiply this to I minus BA and see what happens. So I minus AB is invertible. Mm, Rahul, what should
দাদা
be an yeah?
লাস্ট তিনটে টার্মের থেকে বাঁ দিকে বি আর ডান দিকে এ কমন নিয়ে নেওয়া যাবে।
Mm, okay. Then
তারপর তো ওই লাস্ট দুটো টার্মের থেকে ওই ওই আই মাইনাস এ বি হোল ইনভার্সটা কমন নিয়ে নেওয়া যাবে, তাহলে তো ওটা পুরোটা আই হয়ে যাচ্ছে।
okay, so
তাহলে এটা
a
এ হবে না, আই হবে না।
b a
আইডেন্টিটি
also
ম্যাট্রিক্স,
no
মানে
b
এটা
a
ডান দিকে নিয়ে নিচ্ছ তো।
oh, oh sorry. Oh, so this is basically nothing but yes. So this is nothing but I plus I minus AB na into I
দাদা ওটা
minus
মাইনাস বাইরে নিয়েছো, তাহলে ওই ওপরের লাইনে প্লাস আই মাইনাস এ বি হোল ইনভার্স যেটা লিখেছো ওটা মাইনাস হবে।
eta this one.
এইটা নয়, এইটা মাইনাস হবে, তার আগেরটা প্লাস হবে, আগের টার্মটার আগে আই মাইনাস এ বি হোল ইনভার্স এর জায়গায়।
Why? I have multiplied that by BA, then why shouldn't I
তাহলে
minus?
মাইনাসটা বাইরে নিয়েছি তো আমি, তো
No, I have written the terms
দাদা
explicitly.
এখানে আই মাইনাস এবি ইনভার্স যেটা লিখেছো ওখানেও মানে উপরের লাইনে ওটা
ও আচ্ছা হ্যাঁ
হোল
ওইটা ঠিক
ইনভার্স হবে,
আছে।
আই মাইনাস এবি এর হোল ইনভার্স।
কোনটা where?
এবি মাইনাস এবি, আই মাইনাস এবি ইনভার্স যেটা লিখেছো ওটা এবি আই মাইনাস এবি হোল ইনভার্স
Sir,
হবে।
in the third line where you have written that minus AB into I minus AB, B inverse you have written. That should be I minus AB whole inverse.
Here it is. I can't
হুম
see.
হুম
Right hand side term.
Oh, sorry.
Yes, sir.
and the bracket will be closed
Hmm.
and then we are taking common a.
Here it will
Okay.
be plus, na? Because here is
No,
minus. What the hell I'm doing? There is
then we
zero.
are taking common in the next line I minus ab whole
No,
inverse.
shouldn't it be plus? Because I have.
No, no, no.
সেকেন্ড লাইন থেকে থার্ড লাইনে লাস্ট দুটো সাইন উল্টে যাবে, কারণ মাইনাসটা কমন নিচ্ছি।
Hmm.
এটা প্লাস হবে আর তার আগেরটা
Hmm.
মাইনাস হবে, তাহলে
Hmm. Yeah, now it is correct, I think. Yeah, now it's correct because there will be a zero inside, no? So this is zero, right? What I mean, what you should ask is that how do we get the intuition of this? I mean, how do we know that this is going to be this? So, see, I will show you something like a graph, maybe. So, you are going to have like A minus B inverse, right? You are trying to find it out. So, think about 1 minus x whole to the power minus 1. This is 1 x square, so on. This should be I B A plus B A dot B A plus B A dot B A dot B A. This take I here, B take B common, and take A common at the end of the bracket. So this will be A, which is I B I plus AB plus AB square. Okay, so this is the thing, but this is the term inside is again I minus AB inverse, no? So that's the intuition. Okay, that how do I come up with this exact term? I'm just checking it. But if someone tells me to find out what should be I minus BA inverse, then how do I find the term? That's the way to do it.
Sir,
Hmm. Yep.
uh, sir, uh, in the intuition you did that 1 minus x whole inverse is we know that is
Hmm.
Taylor series expansion is 1 plus x
Hmm.
square and so on,
Hmm.
and you are using this expansion in here that I
Hmm.
minus b a whole inverse like this.
Hmm.
But my doubt is that when we are when we are using that expansion, that x should be a real number, and
Yeah.
here
See, you're absolutely right. That's why it is an intuition. I mean, we are taking the fact that we are actually using this, that if you multiply 1 minus x with this, okay, then it is 1.
okay, okay,
We
got
are
it.
actually using
Hmm,
that. It's not entirely like.
okay, okay.
So what about 9? Use the result of exercise 8 to prove that A, B are n cross n matrices over the field F, and AB and BA have precisely the same characteristic values. So suppose lambda is an eigenvalue of AB with respect to the eigenvector V. So we have ABV equals to lambda V. Oh, so let me write a corollary here for the above. If we replace B by A and A by B, we get that A minus we get that A minus IB is invertible if I minus BA is invertible, isn't it? If you just switch B and A in the above result, you get the opposite. So thus I minus AB is invertible if and only if I minus BA is invertible. Clear? So what do we see here? AB minus lambda I V is 0, which means maybe we should write this way. Lambda I minus AB is not invertible. So lambda I minus BA is also not interval, not invertible, right? Because okay, maybe we should be writing like this. case 1. Case 1. Lambda is 0. This implies determinant AB is 0. This implies determinant BA is 0. This implies 0 is an eigenvalue of BA. Case 2. Lambda not equals to 0. So then ABV equals to lambda V implies lambda I minus AB V is 0. This implies lambda I minus AB is not invertible. But by that we mean that take lambda common, write I minus 1 by lambda E is not invertible. This implies, just a minute, lambda into C. I mean, what does it mean? Take it as C. So I minus CB is not invertible, right? This implies and implied by I minus BC is not invertible, right?
Yes, sir.
So just put it there. Now you can take the lambda outside. It will be, yes, I minus 1 by lambda BA is not invertible. So if you take lambda 1 by lambda outside again, I mean by multiply we get lambda I yes, this is right, by multiplying by lambda is not invertible. Okay, it means so lambda is an eigenvalue of BA. What about this? Suppose that a 2 cross 2 matrix with real entries which is symmetric, prove that A is similar over R to a diagonal matrix. See, this is nothing. Write this A, B, C, C. Okay. Find out the characteristic polynomial and you will see the characteristic polynomial has two distinct roots. Okay. That's it. Wait a minute. Is that the case? Yeah, I mean, just write down this and find out the characteristic value. I mean, then you will realize that it has distinct roots. But wait a minute.
Here the characteristic polynomial should be x square. I think we'll start from this point.
Here it is. Hello? For 10.
No, I think
How?
11.
Yeah. But for 11, what should we do? What should we do for 11? So let's see what is a minus xi mod. What is that? If this is a mod a minus xc c b minus x, right? What is that? A
Sir,
minus x into, yes.
sir, I have a question that A is similar over R to a diagonal matrix. What is the meaning of the statement over R?
Hmm. Good question. So suppose you have been given a matrix say 0 minus 1 1 0. Okay. So what is the characteristic polynomial? X square plus 1, right? So it has no eigenvalue over R, right? X square plus 1 doesn't split over R,
Yes, sir.
but it splits over C. So this matrix is similar to this matrix I minus I. Is it correct? I square minus 1. Right? Over C. But this is similar to a matrix, a complex matrix, not a real matrix. Basically, what this statement means is that suppose A is similar over R to a matrix B, then we mean A is C B C inverse, where each of these are matrices are real. B is real, C is real, all of them. Okay. But it might
Yes, sir, got
happen
it.
that A is similar over, if is not similar over R to a diagonal matrix like this, because because the characteristic polynomial has no real eigenvalue, but over C it is similar to a diagonal matrix. So
Yes, sir, clear.
let's finish this thing. What is x square minus xb a plus b, right? Now what should we do?
Only to prove it has real distinct roots.
Yeah, but the problem is that suppose identity matrix, what do we do with that? It can have repeated root.
Yeah.
Sir, I think the discriminant of this equation greater than equal
lambda
to
1
0.
plus lambda 2 যদি করি যে a plus b আর lambda 1 into lambda 2 ab minus c square
হুম।
তারপর যদি ওই দুটো দিয়ে ইকুয়েশন বার করে
আসবে তো সেম জিনিসই।
হ্যাঁ ওই এক্স
শ্রী-
এক্স এর
শ্রী-
ভ্যালু যদি বার
হ্যাঁ,
করি
শ্রীধারাচার্যটা we can use Sridharacharya. Let's see.
হ্যাঁ,
So x is minus b, that is a plus b plus minus root over b square minus 4ac, right? So b square minus, am I doing it right? Minus b plus minus root over b square minus 4 by 2. So what are these? What are these? So this is a square plus 2ab plus b square minus 4ab plus c square. Okay. So a plus b plus minus root over. See, this is a minus b whole square, na?
So that should be 4c squared.
Sorry, 4c square. Right. So it has no. So case 1, repeated roots. So if the discriminant is 0, right?
Yeah.
Just a minute. If
That
repeated
has
roots
to be A equals to
to
B.
B and C equals to 0, right? So
Yeah.
the matrix itself is a diagonal matrix. Okay. In case 2, if it has not repeated roots, I mean, if it has distinct roots, then we are done, na? Done by. There was an example, na? By 6, I think 7 it was. So what is for 11? Okay. So n is a 2 class 2 complex matrix such that n square is 0. Prove that either n equals to 0 or n is similar to 1. So let n is not 0. Then n is not a 0 matrix, right? So kernel T is non-trivial. Is it clear? Ognidipto and Divya, is it clear?
Yes.
I mean, by non-trivial, I am trying to say T is not whole. I mean, n can be considered as a linear transformation from c square to c square, na? So T is not whole c square, na? Divya, is it correct? Is it correct that T cannot be whole c square, na? Because if T is whole c square, then T is the 0 matrix. But
Yes, sir.
n square is 0. This implies determinant n is 0. So T is not 0 either. Okay. This implies dimension T is exactly 1, na? Because kernel T is a subspace of C square. It doesn't have rank 2, it doesn't have dimension 2 or 0, so it has to be 1. So there exists V belongs to T such that TV not equal to 0, but T square V is 0. Sorry. Right? I have taken this V outside of the T. So TV is not 0, but T square V is of course 0. Because T square is the 0. I mean, oh, I should write it. There is no n, there is no t. Okay, so nv is 0. So take this basis. This is called the cyclic basis of n with respect to v. Take this basis, evaluate this matrix. What is nv? That is 0 into v plus 1 into nv. This is linearly independent, okay? Check that beta is linearly independent. And what is n of nv? That is 0, na? So 0 into v plus 0 into n square v. So n with respect to beta is 0, 0, 1, 0. What about 12? Just give me a minute. Just give me a minute. Hello? Oh. হ্যাঁ 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 ঠিক আছে আমি তো অনেকক্ষণই আছি তুই ডাকছিস না দেখে আমি কিছু করছি হ্যাঁ ঠিক আছে হ্যাঁ
Sir,
just a minute. Hello. So let's do 12.
sir, can you go back in the last slide?
Yes.
Sir, we will check that beta is linearly independent. But in order to show that beta is the basis of, car of n, so we have to show that beta spans car of n.
Yeah, but beta has two vectors and c square has dimension 2.
Okay.
So that's it.
Okay, sir.
Beta has as many vectors as the dimension of the vector space.
Okay, sir, clear.
See, these, I will say solutions are less important. The discussion is more important. So, if you are not being able to participate in the discussion, the chance is very slim that you are going to actually remember all the solutions. Try to understand the logic. Okay. So A is a 2 cross 2. To prove that if A is a 2 cross 2 complex matrix, then A is similar over C to a matrix 1 of the root. Okay. So PAX be the characteristic polynomial of A. Okay. So case 1 where PAX have repeated roots, like it is of the form x minus lambda whole square, or lambda belongs to C. Okay. So this has repeated roots, thus we get a minus lambda I whole square is 0, right? But then you have seen that there is a basis with respect to which e minus, there exists a basis by 11 with respect to, there is a basis beta by 11 with respect to, or maybe I should write such that a minus lambda I This is our n now. Okay, n from the in the previous problem. Put a minus lambda in the previous problem, and what do you get? This. Is 0 1 0 1 0. That is, there exists a matrix P such that P inverse A minus lambda I P is this, because we all know that, I mean, change of basis is just by multiplying by P, pre-multiplying by P inverse and post-multiplying by P, where P is nothing but the matrix of this basis. That is, if beta is these vectors v1 to vn, P is just the matrix v1 to vn, where v1 vi's are columns of P. Okay, so this is the first column and this is the nth column. Okay, so what is P? P is nothing but v11 up to v1n and vn1 up to vnn, and we all know that vi is basically this column vi1 to vin. You write down the basis as columns of P and you get this. So what is that? P inverse AP minus P inverse lambda I P is this. Thus P inverse AP is basically, this is lambda I na, 0 0 1 0 plus lambda I, this is nothing but lambda 0 lambda 1. Okay, so A is similar to this matrix. Case 2, PAX is of this form: x minus lambda 1, x minus lambda 2, lambda 1 not equals to lambda 2. But then A is similar to a diagonal matrix, this, then A is similar to, this matrix, lambda 1 0 0 lambda 2. Okay, by 7 distinct eigenvalues. Okay, 13.
Sir,
Hmm.
sir, I want to know that in the problem number 11 that it is 2 cross 2 matrix. And if we, is there any result that it is true for any k cross k matrix? This result, 11.
In that case, you will have to have, if n is a map from ck to c to the power k, you need to have n to the power k equals to 0 and n to the power k minus 1 not equals to 0. Okay, that the degree
Okay,
of
sir.
nilpotency of A has to be the dimension of the vector space. Then you can do the same
Yes,
thing,
sir. Yes, sir.
just this, take this basis such that V
Yes, sir.
is not in kernel n minus n to the power k minus 1. That's it.
Sir, and for that case, the matrix should be like this.
Yeah, 0 0 1
Yes, sir.
0 0 0 1 0 0.
Yes, sir. Clear.
We have done this problem actually in the linear transformation class. Okay, so don't worry, we will do it again soon. So 13. Have I copied 13? No. First of all, notice that set of all functions from R to R, it is an infinite dimensional vector space. First of all, notice this. The vector space is infinite dimensional. V is of dimension okay. One thing I should mention that though I am teaching in English, because not everyone in this class will understand Bengali, but feel free to ask your question is in any language you feel comfortable in. So the space of continuous real line will be the linear operator. Okay. So suppose lambda is a ch means characteristic value of t. Thus we have t of f is equal to lambda of f, right? Lambda into f. So what was that? Where did the sound come from all of a sudden? Nothing. So t of f at x, it should be lambda f at x. Lambda f evaluated at x is nothing but lambda times fx, na? And what is this? This is nothing but 0 to x ft dt is equal to lambda into fx. Okay. So let's write fx is equal to 0 to x ft dt. Okay. So fx is differentiable clearly. Fx is differentiable, na? Because it is the integration of a continuous function, primitive of a continuous function. Okay. So fx is 0 to x ft dt is equal to lambda fx. Differentiate. So what does it mean? Fx is differentiable. As LHS is, since LHS is differentiable, RHS is also differentiable. So do f prime x. What do you get? But what is f prime x? F is the primitive of f, na? Capital F is the primitive of small f. So you should guess this. That is equals to lambda f prime x, right? So we get this, that f prime x is, sorry, fx is lambda f prime x. So there exists if not equal to 0. I mean, if has to be not equal to 0. For some f, there tf is lambda f, no? For some f, tf is lambda f, and for that if we are doing all these things. Now tell me what should we do?
Sir, it is a first order first degree differential equation. So you can find the solution.
Since if x is not identically 0, we can write f prime x by fx is lambda, right? And then as you are saying, like if we integrate this f prime x by fx, so with respect to say something like dx, this integration lambda, what do we get? We get log fx is equal to lambda x plus some c, na? Thus we will have fx equals to e to the power c into e to the power lambda x, right? But can we evaluate c? Can we evaluate c? What is f0? So I think here we should do case 1 where lambda not equal to 0. Case 1. But what should be our f0?
So we can't find f0.
No. So if lambda is not equals to 0, if lambda is not equals to 0, take this line from 1, we have fx is equal to 0 to x ft dt equals to lambda fx. What is f0 by the way? That is integration 0 to 0 ft dt, na? That is of course 0.
So fx equals to 0.
Yeah. F of 0. This implies f0. This is 0. So f0 is 0. As lambda is non-zero, huh? As lambda is non-zero. So f0 is 0. Put f0 is 0. Then you get e to the power c into e to the power 0 is 0. Which is a contradiction, na? E to the power c is never 0.
Yes, sir.
So this is a contradiction. So lambda can't be 0. Case 2. Lambda equals to 0. If you have lambda equals to 0, then what do you get? Again from 1, from this line, you get fx is equal to 0 to x ft dt equals to lambda fx equals to 0. As lambda is 0, this implies fx 0 to x ft dt is 0 for all x, right? Because the function is 0, isn't it? Fx is 0 means fx is identically 0. It is 0 for all function. Now if was non-zero, right? Because if f is, we are, an eigenvector cannot be 0, na? When we are talking about eigenvectors, eigenvalue can be 0. Eigenvector by definition is not 0, because t is 0 is equal to lambda into 0. So 0 is an eigenvector corresponding to every eigenvalue. Thus whenever we discuss eigenvectors, we don't consider 0. Now this implies there exists A belongs to R such that if A is non-zero. So without loss of generality, let if A is greater than 0. As A is as if is continuous, there exists delta greater than 0 such that if x is greater than 0 for all x belongs to a minus delta comma a plus delta, right? But if x
Yes, sir.
is 0 for all x, this implies f of a plus delta, that is 0 to a plus delta ft dt, is 0, and f of a minus delta, that is 0 to a plus a minus delta ft dt is also 0. But then f of a plus 0 equals to f of a plus delta minus f of a minus delta, which is integration a minus delta to a plus delta ft dt, right? Can it happen? Can it happen?
Sir, it is not possible. It is a
Yeah.
contradiction. Since
But
f is not equal to 0.
we will have to write it a bit properly. It is a C. Have you taken C? No. So take say B dt, where B is minimum of x belongs to a minimum of this set. If t belongs to a minus delta to a plus delta. Okay.
Sir,
Just a minute. Yes. Hello.
sir, actually in Riemann integration we have studied a result that if function is positive, then its Riemann integration is also positive. And since the interval is a minus delta to a plus delta, and on this interval f is positive,
A
so
function
that's
is
why that
positive.
integral should be
A
zero.
function is positive. I mean, it has to be something more. See, a continuous function is positive, no? I can write.
Yeah,
I can
sorry,
rightly. Yeah, I can rightly give you some positive functions like d dc at 1. So yeah, basically I'm proving that it is b twice delta, which is non-zero. This minimum exists because this is a compact set, na? Since a minus delta and a plus delta is closed and bounded, and f is continuous, so we can write this. So that's a contradiction. So no such lambda exists. So apparently this was a problem of linear algebra, but we have had to use a bit of differential equation analysis as well. See, this problem, I will send you the solution because this is a big computation. I will send you the solution, but first of all I will have to check where the solution is. I mean, I will send you it, don't worry, but I have to look for the solution. Please remind me that I need to send you this. I will send you. This is a big solution. What about this? V be the space of n cross n matrices over F. Let A be a fixed n cross n matrix over F. Let T be a linear operator, left multiplication by T. Is it true? First, let's copy the problem. Okay. So V be the vector space of all n cross n matrices over F. So V is Mn F, right? So V to V, A is a fixed matrix. B fixed. So T to V is T. What does T do? T sends B, a matrix of M and F, to left multiplication A B. Okay. So is it true that A and T have same characteristic values? So let's write PAX. This is the characteristic polynomial of A, and PTX is the characteristic polynomial of T. Okay. One thing we should notice: if T of B is AB, then what? T to the T. What is T square B? That is T of TB. It is T of AB. That is AAB. That is A square B. So what do we get is that T to the power I of B is nothing but A to the power I of B. I mean A to the power I into B. Okay. So if suppose fx is a polynomial such that this, and so you will see that A naught into B is of course A naught into B, and A1 TB is nothing but A1 AB, and AI T to the power IB is nothing but AI A to the power IB. If you sum them all, what do you get? A naught plus A1T up to A to the power n T to the power n of B is nothing but A naught, I should write A naught I, A to the power n B. That is f of T of B is f of A times B. Okay. So if you take f to B, so let f equals to P AX. Okay. So write that PA T of B, it is nothing but PA A of into B. But what is PA? It is 0, right? So what do you get? You get PA T divides PA. I should write this. Isn't it? Isn't it? For all B. I mean, what I am trying to say is that PA T is 0. It means the characteristic polynomial, I have written otherwise, right? Right. But what is the degree of PTX? Has degree equals to dimension MNF, isn't it? The degree of the characteristic polynomial is basically the dimension of the vector
Yes,
space,
sir.
that is n square, and PAX has dimension equals to n because A is in an n cross n matrix. So you see a polynomial of degree n square. Wait a minute. No, just a second. What I was trying to say, if the characteristic polynomials of PA and PT are same, right? PT divides PA. But how is that possible? PAT is 0. Okay. Rahul, how to conclude the next?
No, actually,
I think
I am
we should
also
have.
confused.
Sir,
No, no.
I
The
think
thing
we
is,
should.
should have taken the minimal polynomials, right?
Yes, sir.
Yeah.
We should have taken the minimal polynomials. But have I defined minimal polynomials? Have I defined minimal polynomials in the class? I don't think I have defined minimal polynomials.
Sir, here we have to show that PT of x is equals to PA of x, then we are done, right?
No, no, no,
So
no.
we have already
That's
shown
an
that.
overstatement. That's a PA of x is never PT of x because PA of x has degree n, PT of x has degree n square. So it's never true. We will have to show that they have same roots. Okay, just give me a minute. Okay. So what about this? So say let lambda be an eigenvalue of A. Okay. This means AV equals to lambda V for some V, or maybe A minus lambda I is 0. Wait a minute. Wait a minute. So what the hell is happening here? So I have to show that PT lambda is also 0, na? That's what I have to show. PT of lambda is also 0. If lambda is an eigenvalue of A, this means x minus lambda divides PAX. Okay. but our goal is to show this as well. So
দাদা, এই অঙ্কটা এরকম ভাবে কি অ্যাপ্রোচ করা যায় যে ওই দুটো ম্যাট্রিক্স সিমিলার হবে তাহলে?
no, they are never similar, because I mean, one thing you are not taking into account: A is an n cross n matrix, T is a linear transformation between, I mean, an n cross n matrix.
তাহলে অন্য বেসিসের ইয়েতে তো তাহলে রেসপেক্ট তাহলে সেই
A
ম্যাট্রিক্সটা
can
হতে
be
পারে।
considered as a linear transformation from f to the power n to f to the power n, okay, and T is
আচ্ছা,
a linear transformation from mnf to mnf. These are
আচ্ছা
different
আচ্ছা, ঠিক
vector
আছে,
spaces. This is
ঠিক আছে।
isomorphic to fn square, and this is isomorphic to fn square, so these are not same.
আচ্ছা আচ্ছা।
Wait a minute, what the hell is going on? Have I defined minimal polynomial in the class? I don't think I have defined minimal polynomial in the class. Once I defined minimal polynomial in the class, it is done actually. But you have to define minimal polynomial, then you will have to say that a minimal polynomial has all the roots of the characteristic polynomial, only then you can conclude this. Okay, but I think, can we do this? If lambda is an eigenvalue of Px, then x minus lambda into Px. And Px is x minus lambda into some gx, suppose. So what is PAT? So maybe I should write, I will have to show that x minus lambda divides PAT. Or to show that x minus lambda divides PTX, what do you need to check, Rahul? That
So we have to show that x minus lambda is a factor of PTX.
that is PT lambda equals to 0, na? We will have to show that.
Yes, sir. Yes, sir.
But PT lambda equals to 0 in... Okay, I will send you these two problems. Okay, the 14 and 15. I will send you these two problems. Let's move on to the annihilating polynomial chapter. Okay, take this for facts for the time being. Maybe we will prove it. Let's see what they are doing. Use another polynomial. Yeah, they are actually making this an ideal. Okay, so V be a vector space over K, right? Okay. So define a T to be a set. I mean, all those fx belongs to kx such that f of t is 0. Okay. So you can check that this is an ideal actually. Okay. Because if Rx is any polynomial, then Rx into fx evaluated at t is nothing but Rt into ft, which is 0 for any f belongs to at. So Rf is inside at, and if f and g are inside at, that is ft is 0, and if ft is 0, gt is 0, then f plus g of t is 0. This implies f plus g is at 80. So 80 is an ideal of kx. Okay, 80 is an ideal of kx. This is very important line. It may be the zero ideal. That is, it may be that t is not annihilated by any non-zero polynomial. But this is not the case. Okay, we will prove Cayley-Hamilton theorem to show that this is not the case. I mean, I can actually tell that, but then I will have to treat Vx as a kx module. Let's not go there. But that cannot happen if V is finite dimensional. Okay, yeah, this thing is good. This proof is good. Just a minute. Just a minute. Okay, I would request you guys to read. Divya, do you have Hoffman Kunj? Ognidipto, do you have Hoffman Kunj?
Yes.
Read this. I mean, from this. This is page number 191. Is Divya here? Because she is I mean horribly silent.
No, sir.
Sorry, ঋত্বিক যেটা
Sir,
বলছিল,
she left.
she has left.
বেরিয়ে গেছো? Yes,
Oh,
sir.
why?
Sir, don't know.
আচ্ছা,
স্যার,
yeah,
ওই হফম্যান কুইন্সের সলিউশন গুলো করার পরেও কি আর কি কিছু বই করার দরকার আছে?
I don't think so. Hoffman Kunj is the Bible, okay? Like Rudin is the Bible for real.
Yes, sir.
Okay, so I will request you guys to go through from one page number 191. Mm, okay, read till this. Read till this. You have 2 to 3 minutes. Did you read? Hello? Let me know when you're done. Read till this.
Sir, I have a doubt in that line.
What?
Um, Sir, the linear operator T and the matrix A have same minimal polynomial.
Hmm.
I can't understand that line in the first line.
Hmm. What is the minimal polynomial of T?
So the least degree monic polynomial that annihilates.
Yeah. What is the minimal polynomial of A? The least degree polynomial that annihilates A, right?
Yes, sir.
They
Yes,
are saying both of them are same. So
exactly.
basically what
But
they are
why?
saying that, yeah, we will come on to that. So basically what they are saying is that uh, similar matrices have same minimal polynomial. Okay, that's what they are saying. Because see, T can be represented in any basis, na? So in one basis the matrix is A, the another basis the matrix is A prime, in another basis the matrix is A double prime. But if for A double prime, A prime, all of them have the same minimal polynomial of T. Understood?
Okay,
So
okay,
that
okay,
is the
understood.
catch here.
Yes, sir. Got it.
We will go on to prove
Mm-hmm.
it,
Got
don't
it.
worry. But here is I find it fascinating because see, what they're showing that in this remark is that suppose this matrix 1, 2, 3, 4. Okay, this is in M2R. The entries are in real, but this is also in M2Q, na? Q is also a field. So one natural question should be the minimal polynomial of this matrix A in R, is it same as the minimal polynomial of this matrix in Q? I mean PARX and PAQX are the same, but we will prove that these are actually same. So let's read this. There is another basic remark which you should make about minimal polynomials of matrices. Suppose that A is an n cross n matrix which entries in the field F. Suppose that F1 is a field which contains F as a subfield, or real entries F1 is complex numbers. Yeah, we may regard A either as an n cross n matrix over F or an n cross n matrix over F1. F1 is in F subfield. On the surface, it might appear that we obtain two different minimal polynomials for A. Fortunately, it is not the case. And we must see why. What is the definition of a minimal polynomial for A? Regarded as an n cross n matrix over the field F. We consider all monadic polynomials with coefficient in F which annihilate A, and we choose one of least degree. So if F is a monic polynomial over F is of this form, okay, then Fa is 0. Merely says that we have a linear relation such that this happens. The degree of the minimal polynomial is the least positive integer k such that there is a relation of the form 6.5. This is 6.5. There is for that k one and only relation of this form. That is very important. That's very important. They are unique, so there are unique scalars in F such that 6.5 holds. Understood? AT is an ideal, right? Since Kx is a PID, we will come on to this later. Okay, what is a PID? PID means a ring in which every ideal is principally generated. Is a PID Since kx is a PID, we have, AT is generated by some polynomial that is actually the minimal polynomial of this. They are saying that these are in such that these are unique coefficients. Now for each k we have a system of n square linear equation and no blah blah. Since the entries in A lie in F, the coefficients of the system of equations are in F. Therefore, if the system has a solution, yes, the main thing is that if there is a separate set of scalars, suppose there are a1 to ak minus 1 in F and b1 to bk minus 1 in F1, then we are getting two relations in F because these are also in F. Linear operator on n dimension. Only that its degree does not exist n square. Opposite, since the degree cannot exist n. Okay. Yeah, this is the theorem I was talking about. See, the characteristic of minimal polynomials for T have same roots except for multiplicities. So these things we will cover in the next class. Example 2, Cayley-Hamilton theorem. This is a very important theorem. Cayley-Hamilton has an analytic proof, a proof that requires analysis, not linear algebra. See, if you give me the assurance that you are going to read this theory, we can do the problems in the next class. There are basically two theorems left in this chapter. Cayley-Hamilton, a few examples, and the theorem prior to that. This theorem, that minimal polynomial and characteristic polynomial have same roots. Please read this section, I am requesting you guys. Then we can actually solve problems in the next class. Okay?
Yes, sir.
Okay. So that's it for today. Okay. Okay, the next linear algebra class will be on Wednesday then.
Okay, sir.
Devargo, is it okay? Because next Thursday is Kali Puja here.